I thought I would like to say a few words on behalf of Eurecom, to say Eurecom is really pleased and really thrilled to be hosting such a workshop and to be also welcoming such a prestigious and talented community working in the area of open source software for future wireless networking. I also want to thank, I don't know if it has been done yesterday, but I want to thank the team of organizers, Florian Kattenberger, Efan Gauri, Camille who is here, all the team, all the people who have been helping, because I think that they've done a fantastic job. So I want to give them a big round of applause, please, if you can. And sorry, I probably missed some names, but thank you for that. You know, as a young professor, I was hired by Professor Christian Bonnet. I don't know if he's here in the room. I don't see him. Where? Okay. I've personally witnessed the birth of OpenAirInterface as an in-house, initially just an in-house experimental tool for our project. And I saw all the steps, all the progress that the team under the leadership initially of Christian Bonnet and then Raymond Knopp and his teams have done. And this has been just remarkable when you see the impact that this community, the software, has achieved today, the impact globally on the world of mobile networking. This is just incredible progress. So I think I'm incredibly proud as director of Eurecom to have seen this and to be hosting such a team. As a director of Eurecom, I also feel compelled to say a few words about where you are, because maybe some of you know Eurecom, at least most of you know Eurecom as a place that's hosting the R&D lab that has initiated the OpenAirInterface software, but it's actually also a school, and you may see today some students walking around the campus. And I just wanted to say a few words to explain a little bit the puzzle of this very particular concept which Eurecom represents. And here I listed 5 pieces of the puzzle just to explain that, first of all, this is an international organization. This is, in fact, a consortium, and I listed the members here on the right-hand side. It's a consortium of academic interests with top US, no, not US, EU, European universities, maybe one day US, European universities and also companies working together to define the teaching and research policies of Eurecom. This is quite a unique concept, I believe. The other thing is that because of this consortium aspect, this is a very international place where, for example, all the teaching is done in English. There are not so many places like that in France. In fact, in the rest of Europe, there's not so many places where 100% of the teaching is done in English. Another trademark, I think, is the proximity to industry, and this is also one of the reasons why I think OAI could have been designed here, in particular at Eurecom, is because there's so much cooperation and collaboration with industry in all the R&D projects that we have here. And this is very important for us to understand the language of industry, to understand their needs. Now, this being said, I also wanted to introduce, this was the main role today, the keynote speaker, Lorenzo Casaccia. Please come on stage, Lorenzo. So Lorenzo is a prime example of the type of students initially, and then great characters eventually that this school is producing, because he was, I believe, one of the examples of students coming from one of the member schools of this consortium, which is Politecnico di Torino. So he has actually graduated both from Torino and from Eurecom. I think he also studied in Rome a little bit. And he has achieved quite a recognition in the world of mobile networking standards. Today he's leading a very large team for global standards and technology at Qualcomm. I think he oversees R&D and standards in many areas, not just wireless, but I think also wired, multimedia, AI, video, all kinds of areas. And we're extremely pleased to have Lorenzo speaking to us today. I think he will give perspectives of Qualcomm, or maybe your perspectives on 6G, both, combination of corporate and personal perspectives on 6G. And with that, I want you to give a big round of applause to Lorenzo again. Thank you.
It's a great honor. Just to say, it's a great honor to be here. Oh, thank you, Dave. As I told David, it's a great honor for me to be here. Thank you for coming to this talk. So in this talk, I will talk about Qualcomm's perspectives on 6G and also about my own perspectives on some of the things we are talking about. So yeah, about myself, I'm responsible for standardization in Qualcomm, wireless, video, and a bunch of other things. And I've done a few other things in my life. But more important than that is I was a student in Eurocom here in year 2000, and thanks to my dad that keeps all the old pictures, I wanted to show some pictures of me 25 years ago, exactly in the area. So I already didn't have too much hair back then. And I just want to say I'm very personally honored to be here. It's a big thing for me personally. Coming to Eurocom was really one of the sliding doors in my life, in a positive sense. So apart from all of the professional part and everything else, it's really it's a bit of a profound moment for me. So enough of that. I also want to say, as Qualcomm, we are very proud to support this OAI project in general. We've been following that for a while, and it's great to see the progress. It's great to see how much it has been achieved. We remain great supporters of the initiative. And here I'm going to talk about 6G, a little bit of the perspectives or how we see 6G happening, but also why does it exist and what it means. And of course, this talk will not say what 6G is or what exactly will happen, because nobody knows. We don't know. And there are many different opinions. You can just read around in the internet, and we will talk also about some of these opinions. First of all, why does it exist, or why people even talk about 6G, is that the wireless industry has had these 10-year cycles for a while. Of course, one should even ask why these 10-year cycles exist, and there are even, of course, there are people that question why these cycles even exist. Of course, there are people questioning why even 6G should exist at all. It's a fair question to ask. These cycles in general have existed because of spectrum, and in this talk, in multiple places, we'll go around the area of spectrum. And at the end, of course, wireless relies on spectrum, and as time went on, the concept of spectrum and the engineering around spectrum has become more and more important. So spectrum worldwide is governed by these institutions, depending on the United Nations, called World Radio Conference and ITU, and they operate on cycles that kind of are around 10 years, and fundamentally that's the reason why there is a new generation every 10 years, because of spectrum. Because eventually you try to, the industry has always been trying to get, the wireless industry has been trying to get more spectrum. More spectrum comes in this increment of 10 years, and then you generally need new technology, or you have the luxury to design new technology because there is new spectrum. Of course, once spectrum is occupied by some users, you start to go in a mode of incremental enhancements, because of course you need to continue to support the users that are in that spectrum. Once a new piece of spectrum exists, then you can design a new technology, because for simplifying a bit, in concept that spectrum is going to be empty. It's never that simple, because right now there is virtually no free spectrum anywhere on the planet, at least that is usable. So whenever people say new spectrum, what they really mean is that there is someone else there and is going to be kicked out to make room for you. So that's what it really means. But in concept for the wireless industry, that's why the generations exist. So because of this, there are all the generations, they follow a certain cycle, and that's been part of say my day job for about 2 decades, I think. We like to look at it in this kind of way, where you start from basic research or on wireless concepts. Eventually, you try to have proof of concepts for these technologies. And then the key attribute of all wireless technologies, naturally that's why I'm also here, is the importance of standardization. So compared to many other areas of technology, where of course you can introduce new technologies in the market without talking to your competitors, in wireless systems you cannot do that. You know, this is obvious to, of course, everybody that is in the area of wireless, but if you zoom out, it's not so obvious in other areas of technology. So of course, if you design a better engine, you don't need to, you can commercialize it in your car, or if you design a better washing machine, you can just put it on the market. But if you design anything better in wireless, you can just put it on the market per se, because of course it has to interoperate, it has to roam. So all technology in wireless, both for cellular systems, but it's also true for unlicensed systems, ends up being mediated by standardization. So that's why standardization is especially important in wireless. In other areas of technology, standardization means something different. And of course, sometimes people think it's a race to the bottom. But in reality, for wireless, standardization is the heart of technology design, because at the end, all innovation has to be mediated by the standard to become reality. So standardization is really the crucial part between R&D and commercialization. So right now, where we are is that 5G is being deployed. In the standard, people talk about 5G advanced, early discussions of 6G. 6G standards will start next year. What I mean, 6G standardization work. So technology work in 3GPP will start next year. And it will go on for 3-4 years. So the general idea, there is not an exactly firm schedule, but the general idea is that the 6G standards will be completed in 2029. Also, something that we like always to point out is that cellular technologies don't go in this, are very incremental. You know, they have this discontinuity between one generation and the other that we like to talk about, but in reality, like the poet used to say, natura non facit saltum, so it's a continuum. So since the days of 2G or 3G, in reality, what happens is that the standard operates with a mechanism of releases, very much like operating systems on computers. And so every year and a half, there's a new release that brings incremental enhancements. And so from 4G to 5G, or 5G to 6G, it's not that everybody goes to sleep between one generation and the other, but there are all these intermediate steps. And this is another way that we like to look at it. You know, this is a reason I'm showing this is also to share the mental model that we have on how to look at cellular technology. Cellular technology nowadays has become huge because cellular technology is everywhere, not only in mobile phones, but it's used in many different areas. But, you know, a way to look at it in terms of mental model is like this. You know, we try to look at it as a tree. So there are technologies that are fundamental to 5G, many of which have their roots in 4G. So that's why, like a tree, it has their roots. And then there are variants of the technology that are the branches, which are, for example, 5G for satellite, or 5G for IoT, or 5G for cars. And then there are the leaves that are the myriads of small additions to the standard. And we like to show it like this because sometimes the standard is very complex and people don't understand what is the core technology of 5G or not. But like very much like a tree without the leaves is still a tree, or a tree without the branches is still a tree. Same for 5G. There are things that make 5G, which are the fundamental technology of waveform, modulation, coding, or multiple access, and there are things that are just additions, and without them, 5G will still be 5G. So 5G for satellite or 5G for automotive, these are extensions of the standard, but are not the core part of the standard. We without them, the standard would still be 5G. So we like to show, we like to present this to, and give a kind of a mental model of how to approach the complexity of the standard. And this is what the tangible manifestation of what I meant. I'm not going to go through all of this. But it's just a way to look at it, that 5G was started, of course, almost 10 years ago now, about 7, 8 years ago. And release 15 contained a number of features, and every release has added more and more features. So this is everything that I talked about in abstract, how it shows here. Now, what is important now that we are in this phase between 5G and 6G? As I mentioned, of course, researchers, and industries, and companies are starting to look at 6G standardization. But in the meanwhile, the 5G machine continues to move. And these 4 are the main areas of focus for 5G right now. Especially, it's very, maybe the 4th one has become especially interesting, especially popular in recent times. So the use of 5G for satellite, this is, I will also talk about it later, but any time is good. It's been a very, since we are in France, there's a major French company, which is Thales, that has been at the heart of this movement. This has been one of the most interesting evolutions for cellular. In fact, actually, it's nothing to do with cellular because it's satellite. But what has been happening is that, because people are familiar with the fact that satellite systems are kind of still in their 1G days. So each satellite system uses their own proprietary interface. And since 2017, the satellite industry, or at least parts of the satellite industry, have gradually been interested in developing a standard, a common standard for satellite access. And instead of doing it elsewhere, they came to do it in 3GPP because they wanted to do a standard using a variant of the cellular system. And this has become very interesting because for some companies, this means that you already have the same building blocks for cellular technology that with 80% could be reused to provide satellite access. The context of all of this is that throughout the years, cellular technologies have struggled with coverage for a long time, so they've been trying to have improvements in the uplink or challenging coverage solutions. Many of these solutions, because they address also the more complicated link budget of satellite. So anyway, this has been a very, very long project. We're in 2024, and all of the project of doing satellite into doing satellite towards mobile phones or leveraging cellular connectivity has been going on for a while. Of course, in the meanwhile, everybody knows there's been SpaceX, reusable rockets, Starlink. This is also, in fact, given an impetus to the satellite industry to try to do something new. And lastly, it has created a lot of interesting dynamics because now satellite companies want to use cellular technology, but satellite companies operate in satellite spectrum, and creates all those industry dynamics between satellite companies and cellular operators, whether they are partners or whether they are competitors. Anyway, I just wanted to mention this is a very interesting area. In fact, just yesterday or 2 days ago, there's a company called Skylo has announced, there's announcements all the time, but has announced now commercialization of narrowband IoT over NTN. This is a project that we've been working Qualcomm with them for a long time. So narrowband IoT is an IoT technology developed many years ago by 3GPP, and now it works also over satellite, and it's a standard. And so you can do satellite IoT in a standardized manner. And then you can do the same thing integrated in mobile phones to have a standardized way to do emergency messages in the same way that the iPhone introduced some time ago. So there's a lot of interesting things happening in this space of satellite plus cellular. So what is happening for 6G right now is that 6G is in this sort of pre-standardization phase. There's all of these regional groups that are mentioned here. So every region has a sort of 6G group, and these are places where people discuss with each other. And then there is the ITU, where people discuss spectrum, and then eventually there is a 3GPP, where people will discuss the technology. And these are some of the use cases that have been talked about in the industry, and in fact, FreeGPP already started to discuss the use cases, so these are the use cases that the FreeGPP standard has been talking about. Of course, some of them are a bit vague, you have to be translated into technology to really make sense. Of course, the biggest question about this use case, about this set of use cases, which again is another fair question, is that several of them refer to non-human traffic. Right? So there is a whole theory, which actually goes counter to my entire talk, but I think it's intellectually honest to talk about this. There's a whole theory about the fact that you don't really need new generations or new advancements in wireless. There are, of course, some reputable people or academics that have been talking about that with reasonably sensible arguments. So it's good, of course, to hear the other side of the argument. And many of the arguments that run counter to any wireless innovation are due to the notion that for humans, there's more than enough. Like humans more or less have what they need and they cannot consume more information than what they have now. And so why bother to do anything? And for the counter argument, which is a subtext to this slide, which is not just a Qualcomm slide, it's really a slide that comes from what the industry looks at, is that there is more traffic coming from non-human use cases. And that is a fundamental question, I think, for the whole wireless ecosystem. Whether this turns out to be true or not, of course I don't know, but it's a very deep question or fundamental question, I think, for wireless evolution maybe in the next 10, 15 years. Is there evolution? Is there an evolution of use cases due to non-human traffic or not? You can have both types of the argument. And that's why this slide shows is a beautified version of what the ITU looks at for 5G. So there are the three arrows. There is an hexagon because 5G was a triangle. In 5G there were three vectors of design of 5G. There was mobile broadband, mission critical services, and massive IoT. And then the ITU identified for 6G an evolution of these three, plus three more aspects, these immersive services, spatial perceptions, or social sustainability. And apart from social sustainability, the other two, they refer a lot to new types of traffic that is not necessarily related to human services. And so then these, they would translate to new type of technologies or new type of use cases. Now we're going to talk about a little bit what are the things that people talk about in the industry, trying to put together also the point in favor or the counterpoint. This again, this is the research program coming from ITU in terms of 6G, so there's a lot of this, is a different representation of what I showed earlier. And there are some KPIs, so these are the official KPIs for 6G that in theory any new design will have to meet. So first of all, there is a spectrum aspect. Spectrum is very, very important, as I said, because the fact that there is new spectrum or there may be new spectrum is the real reason why people would do new generation, because they can do new generation because you can afford to have a new design where there are no existing users. So in many of the bands that are pictured here, there are already existing users, but in some, there are not. So for example, the same slide before can be shown here. This is maybe a very interesting slide for people who want to understand wireless and maybe are used to think of wireless in terms of just modulation, coding, etc. This is a different way of looking at wireless. You can look at all the spectrum that is used today or that is allocated today or that is considered today. And you can start from the bottom. It's very low spectrum, 600 megahertz. It's very close to, in some countries, including in Europe, there are broadcasters where you get your TV signals, but in other countries, the TV stations have already been kicked out of that spectrum, and so right now there is 4G or 5G. And then as you move up, there are the old bands where you had GSM, looking at faces, many people, of course, many of you had GSM phones, I'm sure. So there were GSM phones, And then as you move up in this picture, there is a 2,000 megahertz, 2 gigahertz. That's where you had 3G. And then as you move up, 2.3, 2.5, that's where we're 4G. And then in some places 5G. And then as you keep moving up, 3.4, 3.6, this was the key band for 5G in Europe or in China. And of course, I should say, this picture is made more complicated by the fact that there are variants of this picture for every region. And that's what makes it more complicated. So this is kind of the canvas that then is slightly modulated in every country or in every region, depending on, in Europe, the spectrum management is Europe-wide. In other places, it's more, in China, is only China, for example. And so what is interesting nowadays in this area of spectrum is the part in the upper right side of the slide. So the so-called 6 gigahertz spectrum. So if there is one topic today in the world of 6G that is contentious or interesting or I could say kind of exciting is the 6 gigahertz spectrum. Why? Because the 6 gigahertz spectrum in the US has already been identified for evolution of Wi-Fi. So there is going to be Wi-Fi 8, Wi-Fi 7, Wi-Fi 8. And in China, they've already identified it for 6G. And in Europe, there is very interesting debates, including an array of research ideas, some of which promoted by the UK regulator Ofcom or by various companies, about what to do. So there are ideas about whether Wi-Fi and cellular can share spectrum. And spectrum sharing has been discussed for 10 years. Of course, there are some people that argue that the two technologies sharing spectrum has been attempted for 10 years. It has never worked. Why should it work today? And there are other people that say, no, for 10 years we didn't understand anything. Now we have some new way of doing it. So this time it will even work. Of course, this is made more complicated, as I said earlier. The spectrum is not really empty. It just appears empty, but there are other things. There is radio astronomy, meteorological stations, which of course people consider of lesser importance sometimes, but of course they are there and they don't want to go away, and so you need to further share or discuss with those other stakeholders. So but this is just to show what does it mean to do 6G. What does it mean to 6G? You need to find a place to put it. And nowadays, this is the most interesting discussion, is the 6G, is the 6 gigahertz spectrum, 6 gigahertz for 6G. So for those interested, I invite you to follow that, that particular part. And so, okay, the drivers for the interface design, of course, some of the drivers are well known, you know, the improving efficiency in all metric. And let me try to go to some of the use cases that try to motivate for a new design. One thing that the standard is starting to talk about is this concept of digital twin. Of course, also this one. Sometimes it's controversial. People think it's more or less serious, and is a good example of what I mentioned earlier. Is a source, according to the proponents, this is a source of major traffic that is non-human. So this would relate to acquiring information about the physical world in order to represent it somewhere else digitally, so that it can be processed or analyzed, or actions can be taken far away from where the physical world is. And in order to transfer real-time information about the physical world, you need a lot of communication or a lot of data transfer. So this would be a major source of traffic that has nothing to do with humans or watching videos on Instagram or anything like that. It would be this sort of reflection of the world. So this is a very interesting use case. It would be a motivation for doing traffic. And the related technology aspect to this is the concept of communication and sensing being merged. So what is this? This is again, is a gradual idea that in reality it started since 5G. So as technology, directionality of the wireless technology is improved with 5G, there's also been the concept that you can use wireless signals to sense the environment. So as a sort of a radar. So we already know there are radars, they sense the environment. you send a signal from the reflection, you can sense what happens. And of course, one can argue why you cannot do the same with cellular systems, which at the end are almost ubiquitous. And so you can use communication systems also as a sort of sensing. And so this is it relates to the earlier point about digital twin. And this would also be another fundamental source of traffic that is non-human. And then so you can sense the environment and have this sort of radar that then you can use for traffic monitoring, optimizing this or optimizing that. I should also say that what is a counterpoint, just not to be too optimistic or not only about the 6G propaganda, but what is the counterpoint to this? Of course, this has to happen in some spectrum, and the spectrum of 6G is the spectrum controlled by mobile operators. And for better or worse, mobile operators don't have a good track record of generating innovative services like this one. So one thing, of course, is the vision of realizing something like this, and another thing is to execute it in the real world, which maybe has to do much less with technology and more with operational ability. So this is always what leaves people a bit skeptical. So, of course, one thing is the idea, the other is the actual realization. There is also the other aspect that in cellular systems, of course, are based on dedicated spectrum, and in every country there are usually 3, 4 wireless operators. They have each their own dedicated spectrum. So what would this mean, that you would have 3 different sensing networks? Maybe, maybe not, it's not clear. Another big topic, which also people always like to talk about, is applying machine learning, AI to wireless, because this is very fashionable, clearly nowadays. It has already started in 5G. Concretely, what this means is that you can improve a lot of the signal processing. You can improve a lot of the signal processing aspects using AI between a modem and a network. So a lot of the wireless system is based on MIMO. MIMO is based on feedback, because nowadays 5G is all based on TDD, so it's based on reciprocity, so it's based on channel state information that is sent by UE, by a phone back to the network, and then the network can optimize the weights of the transmission towards the UE and on and on. And all of this can get better with machine learning. So this is an active area of work in research and in standard. Now another big theme. Earlier I mentioned that there is a focus, increased focus on what is called social sustainability in wireless systems. Concretely, it means this. It means energy consumption. In France is a topic that especially French companies are very sensitive to, even though, of course, in France there is plenty of energy. And that has to do with the fact that radio access networks and mobile networks are a big contributor to overall energy expenditures, especially radio access networks. And so there is a whole array of discussions which are very nerdy, and you can see a lot of acronyms on the right-hand side of the picture on how you can optimize that. At a very fundamental level, what this refers to is whether you can switch on and off radio access base stations in more or less real time. If you look on a longer arc of time, all of these things is complicated to put in the slide. All systems, all cellular systems, they've had some form of a pilot. So in GSM, there was the BCCH that was hopping, and then in CDMA systems, there is a continuous pilot, and that would use 10-15% of the power of the cell. And then things have gotten better and better, with inverted commas. So in 4G, there are the so-called cell reference signals, which are a form of a pilot, so a persistent signal in every cell. In 5G, there have been fewer persistent signals in each cell. And then the idea is going towards 6G to have, again, fewer and fewer of these persistent signals, so that then the radio access network can fundamentally be optimized switch on, switch off. Some parts can be switched on, or switched off on command. This is a general technology trend to try to have a more dynamic network in terms of energy consumption. Then, very related, of course, I'm getting towards the end, very related to also the topic of the workshop, there is this big trend about open networking. This will be a big topic for 6G. And what does this refer to? It refers to, fundamentally, disaggregating the infrastructure into a possibly higher number of individual elements with open interfaces between them. This is the logical representation. This is what we would call a logical network. From a tangible point of view, what this means would be to move from integrated, fully vertically integrated infrastructure systems to more dynamic relationship between silicon and software. So this is really the underlying meaning to this slide. So basically it would mean you would have general purpose processing, general purpose silicon. That's why all the silicon companies are, including Qualcomm, of course, Qualcomm, Intel, AMD, NVIDIA, they are all interested in some degree in virtualization, because as these nodes break up, they become more like computers, and therefore there is a processing element that computes, and then the cellular specific functions are software, are just software on top. That's of course where the OAI project fits into this. It fits exactly into this trend. You can argue this is a secular trend of wireless systems to move away from deeply vertically integrated systems to more just like compute system, which again, as I said, is a secular trend. Within the wireless world is very politically controversial. There are a lot of aspects related to China and the US, but in practice it's just a secular trend. It's the same trend that has led to the emergence of the cloud, or AWS, or Google Cloud. It's just the same thing. If you just zoom out, it's the same fundamental thing from when you started to use you wanted to do a startup 30 years ago. In fact, it was very difficult to do a startup because you needed to have your own servers, and then now if you want to do your own startup, you can just buy some capacity from AWS. And then, just one this point I wanted to mention, which is very related to what I said earlier about the fact that a natural challenge of every new generation or wireless innovation is that there are, in a country, there are typical 2, 3, 4 operators, and of course they have to compete, which also means they have to split the attention or all try to do the same thing, which in a world of hyperscalers, like I said earlier, it's very difficult. So there is this concept, which is not new, but is becoming more popular, which is about sharing the RAN, sharing the spectrum. This, again, as I said, is a relatively old concept that has been existing forever. So where 2, 3 operators pool their spectrum together, and they run a single network, and then they operate different services on top in a virtual manner. But it has become very popular because in China it has been done in a grand scale, and many things in China happen on a very grand scale. And so for 5G in China, China Unicom and China Telecom, which are the second and third operator, but still they are gigantic, these are enormous operators, they completely share their network. And it's been a very successful experiment. And of course, by being able to pool more spectrum together, they're being able to do more things. And because that has been successful in China, now people look at this more seriously for 6G elsewhere in the world. So this is another interesting technology trend. That is a parallel to what I said earlier. So more open infrastructure, meaning more decoupling of silicon and software, and at the same time, more pooling of spectrum. The two things, they go hand in hand. And then finally, as I mentioned earlier, cellular has grown tremendously, and I already talked about earlier about satellite, or also Wi-Fi. There is this continuous desire to integrate these different communication networks with each other. especially satellites, is very interesting. It's very interesting nowadays, because also we all want another perennial problem of cellular systems that people like to talk about is ubiquity, or that continues to be areas without coverage, whereas some areas have excellent coverage. Of course, satellite helps with that, and if the technologies end up converging, it makes this union easier. And with that, that's all. I mean, many of these topics, Qualcomm has videos on YouTube about, if you want to go deeper, so you can go. At least if you want to hear the Qualcomm version, the extended version on many of these subjects, you can go on YouTube and watch our videos on a lot of this. And with that, I thank you. And it's been again a great time.
All right, thank you, Lorenzo. I'm sorry, David had to step out, so I'm taking over. So thank you very much. We have time for 1 or 2 questions from the audience, if there are any. Yes?
Hi, Lorenzo, thank you for a great talk. I wanted to know if you have anything to say about the terahertz from the cellular perspective.
Oh, yeah. That's a very interesting question. It's true, I didn't talk about terahertz at all. And so terahertz, of course, for other people are very, very high frequencies, of course, in the terahertz range, which also means they're very short range. And until a couple of years ago, there was a lot of academic buzz on 6G with terahertz. I should say, in general, that buzz has receded greatly, and I would say people don't talk too much about it. Of course, it's even intuitively hard to comprehend how you can have a cellular system that has anything to do with something that has a very, very short range. And but of course, you can always have different sides of the argument. Personally, I don't think it makes so much sense in the context of 6G. It's yeah, I think in all these topics related to 6G, in order to make sense, in my opinion, just my opinion, they need to have some fundamental attributes, like it has to make sense to have a long-range communication. So to have cells, otherwise you can use other technologies. And many of the use cases are predicated on the fact that there is going to be a technology that goes into smartphones. And because it goes into smartphones, and there's more than 1 billion smartphones sold every year, there's a huge economy of scale. And then the same technology can be applied to many other adjacent areas. Right? This is the fundamental theme of wireless, including for satellite. For terahertz, this kind of argument about adjacent areas becomes very, very weak, because it's not even so clear that you can reuse anything you do in a smartphone for terahertz. So it's not as exciting as it used to be.
Any other question?
There's a colleague out there.
Thanks, Lorenzo, for the talk. One question related to the non-terrestrial communication. I mean, could you shed some light on when Qualcomm is anticipating a market deployment of such technologies?
Non-terrestrial network?
Yeah, for the phone. Sorry, for the UE.
Oh, very soon. Depends for very soon. Very soon, actually, I don't know if maybe we already announced something or not. Yeah. Actually, I should.
So this means.
But I don't remember. But for use case of, let's say, emergency notifications into phone based on 3GPP standard, very soon.
Okay, so
it's
mostly for short messages.
Mostly for short messages in the short term. Mostly for short messages. Yes, absolutely. Actually. There's already been very small-scale commercialization happening. I think a demonstration at last Mobile World Congress for these public service use cases, but for mass market, as I said, either it's already public, or if not, it will be sometime soon. And then for mobile broadband, that will take more time. And the reason why it will take more time for mobile broadband is because you need also better satellites, and so doesn't depend only on, let's say, the receiving end, that would be Qualcomm, but also you need people to launch satellites supporting the standard. But for the short notification, yeah, as I said yesterday, there was an announcement already from Skylo. You can just look on the internet, this company called Skylo.
Thank you very much.
Yes, thank you for your presentation. One question. Do you think 6G is also a topic for the private smartphone users, or do you think it's only for special use cases or something in the industries?
What is private?
So, like all read together with our smartphones in 10 years, that also 6G is for the smartphones?
Yeah, of course, 6G will be for the smartphones, for sure. I think it comes natural in the sense that, I know it's maybe it's a boring answer or a simplified answer, but there is going to be new spectrum, and the new spectrum will be supported by new phones, and new phones naturally will support 6G, and that will give the economy of scale to support all the other things. So yes, it will definitely be in the smartphones. Yeah.
Thank you.
All right, I think we have to wrap up in the interest of time, so let's thank Lorenzo once again. Thank you very much.